Hi, so we're going to start talking about operator overloading. We'll talk about it in the context of the built-in types first. So before we get into the details of the operator overloading, let's do a quick review of the dunder methods first. And this is the person class that we've seen quite a few times. And we define the dunder init and dunder string method. And we know that when we instantiate an instance of the person class, even though we did not explicitly call the dunder init method, it is automatically invoked, right? And the same thing for the dunder string method, even though we did not explicitly invoke it here, when we want to print it, well, the string here is actually unnecessary. But anyway, when we need a string representation of the instance of person, this dunder string method is automatically called. So we know these dunder methods, they are special to Python, and they're useful not only because they can be invoked automatically at the right time, but they also allow all types, and whether it's a built-in type or user-defined type, the same access to some special and simple syntax. And these syntax could be like arithmetic operations such as plus, multiplication, etc., and like the indexing operation in list. So so this second ability it actually allows for a very simple and standard way to use all types, and it's called operator overloading, and that's what we're going to be studying. So just a word before we proceed is some languages supported such as C++, Java, however, on the doesn't, and so it's not strictly necessary for a programming language, but it can be useful when it's supported. So speaking of the plus signs, let's actually see how it works for two built-in types that we know very well. So first is a list. So I have a list of two lists of numbers here. I can concatenate or add the two lists together, and we'll get one list. And the same thing goes for if the two operands to the plus sign are integers. And again, I can use exactly the same syntax, like a plus b, and it would add the two integers together. So the thing of note here is that the last two statements here, they are exactly the same. However, because the operands, they are different types, and so they do the plus sign, it does a different operation, and the results are also two different types of results. And if we look behind the scene of what the actual plus operator does, is that it actually invokes um, a special dunder method. And in this case, for plus, it invokes the dunder add method. So I actually type out the code here, and so we know what this does. And this is exactly the same as that. So a dot dunder add b, and that would give us exactly the same result. So, well, what about if a and b are integers? Well, it's actually exactly the same. Um, if we define a and b as integers, we know a plus b is going to give us a 3. However, that's just syntax. What it actually does, again, behind the scene, is that the integer class, actually define a dunder add method that is called when the operation is a plus b. So this is exactly the same as a plus b. So this would give us a 3. So a quick recap is, again, because a is a list, and the list actually defines the dunder method, dunder add. So when we write the a plus b, Python knows that it should call the list dot dunder add for this particular special syntax of using the operator plus. And the same thing if a is a type int, and int defines a dunder method that is dunder add. So when the Python sees the syntax a plus b, it knows to invoke int dot dunder add to add the a and the b, these operands together. So putting the two things together, then we can see that these two syntax, it's using exactly the same operator, which is the plus sign, but they do different things depending on the type of the two operands. So that's why this is called operator overloading, because again, same operator, but it's overloaded to do different things depending on the type. And operator overloading is a very fine example of what's called a syntactic sugar. And what that is, it allows the code to kind of look like or use notation, in this case plus, that's very close to its target domain. So in this case, it's the target domain is doing the integer operation, right? And a plus sign is a syntax or a notation that we are very familiar with. And so, and the way that the Python defines it actually allows operator overloading to also be used in user-defined type, and we'll talk about it in a second video. So, and the reason it's called syntactic sugar is just because it's a lot nicer to write a plus b rather than, kind of int a or just a dot dunder add b, which, we are, again, a lot more familiar with this than we are with this. So this is, in a way, sweeter than this syntax. And now you can probably imagine that there are other special dunder methods for, let's say, subtraction and multiplication, etc. And there are, and we will explore them in more details. But for now, I'm going to show you something a little more fun, and it's actually retrieving a particular element in the list. We use the bracket, square bracket syntax, and it actually also have an equivalent dunder method called getItem. And so getItem takes a single parameter, the index, which is what we put in the square bracket, and these two lines, they do exactly the same thing. So if we run them, item at index 1, that's the element 2. And not only you can do this for getting the item, there's an equivalent method for setting the item. So if we want to set the element at index 1 to 22, we can do the same thing with a dunder set item. And so the first parameter is the index 1, and the second parameter is the new value. So if we set it to 22 and we print out the list, and yep, indeed, the element at index 1 gets set to 22. Now, in fact, this idea in Python is not only limited to operators, they extend to built-in functions. So for example, the built-in function length, calling on a list, really just call the list's dunder length method. So these two would give us equivalent results when we run it. So they both will return 3. Although this really isn't anything new, because it's the same idea for the dunder string method, that when we use the built-in string method to get a string representation of a particular object, it really just calls that object's dunder string method. So yeah, same idea. So now I'm going to ask you to try this yourself, that for the built-in string class, and these special operators or syntax, such as when you add two strings together, find the dunder methods that these operators actually call, and also prove to yourself that both the special syntax and the methods, they are equivalent. They do exactly the same thing. And I particularly ask you to try the square bracket for both read and write, because one of them might do something slightly different from what you may expect. I am going to end the video here, but please do make sure that you give it a try.